In this online lab for static fluid pressure and fluid flow, we'll be using a phet simulation in order to explore ideas around fluid pressure, gauge, and absolute pressure, as well as the pressure due to a fluid at a certain depth within that fluid. And then we'll also look at the flow of ideal fluids and the application of the equation of continuity. You're going to go to this website, which is listed in your lab manual, or if you just go to Google and you Google phet fluid, then you'll get the very first link, which was like this. And then you can either click play or download the Java version. I've clicked play, and I now have this window up. This is as it appears to you. A couple of things to note here is that you will need the grid, and the grid will show you the different depths. So here this is 0 meters, and then 1 meter, 2 meters, and 3 meters. And then you can also fill up the container of water in this case. So now I have water and I have it filled up to 0 meters. If you want to drain some of the water, then you can do that down here. Just, so you have a towel on the floor or whatever to pick up the water. I'm going to fill it back up again. Then also I can use this as a pressure gauge, and I can put it wherever I want. I can have it go at any depth of fluid. I can have it up here. Also, this is the default, but make sure that you have this set at 9.8. But notice that if I have it set at some other value that is lower, that makes my pressure go down, that then the weight of that fluid is just less. It still has the same mass, but it has a less gravitational weight, and so the pressure of that fluid is going to be less. Let's see if I can get back to 9.8. By the way, you can always just type it in. So also, there's a ruler here. If you need the ruler, you can use that to measure the different distances, but the grid is just fine as well. One of the parts of the lab has you deal with gauge pressure, absolute pressure, and then atmospheres. You can use that here. And then also you have to go between different densities of fluids. So if you come here, you can click on fluid density, and then you can go from all the way from gasoline, which has a relatively low density, all the way up to honey, which has a relatively high density. We'll be using water, though you might want to change for some parts of the lab. Then we get into the pressure at different depths. So you have a phet simulation that looks like this. If you go here, and you can click on different configurations. So I'm going to click on this one, and then I can fill it up. And get rid of this ruler, and then you can answer some of the questions regarding pressures at different depths for that section. The final part of the lab deals with fluid flow and the equation of continuity, and we're going to use the same phet simulation, but we're going to come over here to flow. And in flow, what you have is an ideal fluid flowing through this pipe that's been cut away so you can see what's inside of it. And I can change different things about this. I can change the area of the pipe. Use the flux meter. It's really useful to show you what the area is instead of calculating it. I can use this to find the area. So if I make this pipe bigger, for example, then the flux meter will report to me the area of 12.5 meters squared. It also gives me the flow rate of 5,000 liters per second, and then also the flux rate. We're not going to get into flux in the 101 or 102 classes, but if you're in the 200 level, you'll learn about flux when you deal with gravitational fields. So just sort of tuck away this information that flux is a thing that you'll need to know eventually, that you'll use for a particular purpose. Notice already here that as I've made this a bigger area, that the velocity of the flow seems to have slowed down quite a bit, and I can show that by putting my speed meter right here. It's at 0.4 meters per second, and then I can put another one over here, and notice that indeed it is decreased as it goes through that larger section of the pipe. The lab actually requires that you look at that. Also notice that you can change the fluid density over here. And see, I think that's all. Yeah, I think that's all. It's actually I think the simulation is actually pretty simple to use once you play around with it. So spend some time just playing around with the different variables, and then notice that you can always reset all. So you can always get back to the default position by just pressing reset all, or you can restart your browser, I guess, but just press reset all and that'll get you back to where you started. All right, let us know if you have any questions, and I hope you have fun with this.